Welcome back. We're writing Little Man Computer in C++. We have moved on to the assembler section of the project, and over the last few episodes we've been handling the conversion of a set of pre-processed instructions into assembly language, into machine code numerical values. And what I guess we want to do now is there are two stages left of the assembling process. We've been working backwards slightly here from the final output. The remaining two steps are to construct a lookup table of address label identifiers. If we have a look here at a sample program, you can see various instructions are labeled here and then referenced as addresses throughout the program. So that's one part. The other part is to parse each individual line into its component parts of a label, an opcode and an address, and to trim out any comments or any, I guess, blank rows that happen to be in the program. So it feels like the easier of those two is to deal with taking this set of labels and extracting their address, and it's relatively straightforward in the context of Little Man Computer assembly code, because each instruction is a single memory location, and so each line represents a single memory location, and we can go through and essentially just store the line number from 0 where each of these addresses occurs. So if we go back to our code and jump down to the bottom here to our assembly tests, we can start adding something with this structure here with a name. What is a name? Let us not even bother with the name. Let us start with an assertion. So we want to assert something about the addresses of labels. So assert are equal. We'll want to do something like assembler dot label dot address for label, like so, and it's the other way around. 42 doesn't really matter what the value is. So we want to look at something like this. Now, interestingly, in our production code for the assembler, we've looked inside the private space of this class and pulled stuff directly out of the labels. Out of the labels map here, and that's possibly going to want to be refactored when we have a proper API. We probably should have developed this at the time in the previous set of tests, but we didn't, and that's where we are. But there is only the one use there, so it should be relatively straightforward to deal with as introducing a member function. So where do we want to go from here? So we need an assembler, like so. Boop. That's a good start. And we need to do something like assembler.add label. No. That's not quite what we want to do. We want to do assembler.assemble instructions. Ooh, no. Interesting. So we need some other function here because we're going to have some sort of two-pass system. We want to extract label addresses. Somewhat verbose, but it'll do for now. So if we make, we'll see. Oh, naughty! No write since our last. Yes, but that's fine. So we're missing some. Let's just write. So we do have the full set of errors. So we're missing an extract label addresses and an address for. Yep, and that should be instructions as well. So we should be able to edit the assembler header file and add in the relevant API. So we want to do something like int address for consted string label, like so. And we also want to do extract label addresses with our set of instructions. And if we make there, we should find that. What have we done wrong here? Ah, that's good. So we've got to the point here where we don't have any instructions, which is fine. So we want a vector of instruction, like so, and that 42 is going to really bite us if we leave it there. So we won't leave it there. Was I working along those lines before? We kind of want that as the simplest possible case. And label, doesn't matter what our instruction is here. And we don't need an address. So that should be the resultant value for that particular set of labels. Part of me doesn't want to start on 0, but I think that's the most straightforward case. So we're missing some API here. So we're missing int LMC assembler label for our label. That's not what we want, is it? It's address for, and I've completely made a mess of the API here. That should be address for. Oh no, it is address for. I've just misremembered what I'd written. So we need that API, and we also need extract address labels, label addresses with our instructions. It's interesting that instruction there does not need a prefix. Weakness in my understanding of how namespaces work in this context. I shall have to find out about that later. Okay, we have an unused parameter. Yeah, all sorts of interesting things here. So let's clear up those so we can see what's actually going on. Maybe unused, and it certainly will be unused in the first case. And that needs to return a value, and it feels like -1 is a good value for it to be, as we haven't set it to anything. And that looks like it's going to compile okay, doesn't it? Good. We do not have a name, so we do need a name for the test, and that is going to be label on the first instruction has address 0. That seems plausible, isn't it? So we should find that running that fails the test in the expected manner. I mean, we've only changed the test name, so we could already see that that test is failing. So the easy pass is just to change this to 0. That should give us a passing test, and then we can move on to expanding to additional labels and see what that does. Good. So then the next test should be something very similar. We'll move on to having a label on the second instruction, which will be a 1. We can do this by just inserting another instruction, like so. The rest will be completely fine as is. I'm going to just do this so that we can't cheat. We should find that the first test fails and the second test passes. Sorry, other way around. First test passes and the second test fails. And that should be relatively straightforward to make pass in here. What is the most straightforward way to make it pass? We can cheat here. We can just write out the two. I'm going to change the tests before we try and do anything here. If I make this label as well, I can't just give two separate values for the labels explicitly. Label will have to have two different values in each of the different tests, and then I can't cheat by just predefining them, if you see what I mean. So what I will do, I will have to extract in some manner the real answer. Whether that's a good thing or a bad thing, who knows. So my ability to do this is going to be the way I'm going to do this is probably the simplest way. Whether we've jumped too far ahead with our tests is another question, but I think I'm happy with having only 2 lines of code being generated by the test here. And okay, it's 3 lines of code, I've lied. If instructions, I don't need this if statement because it doesn't matter. So what I can actually do is I can say add label instructions I dot label and r equals I. I think I can just do that, What have I done? I've typoed instructions. Oh dear, let's not do that. If I just that's interesting. Instructions, no, that's why. Let's write that again, shall we? Label, oh no, add label, instructions I.label I. I can do it that way. And here I've spelled that wrong. And here I've got the maybe unused that's no longer necessary. A little bit of messing around there, but I think we're back in where we want to be. That's that should be okay, shouldn't it? Oh, no, we're still failing there. Why are we failing? Why are we failing? Because we're returning 0. That's why we're failing. Nope. That wants to be labels label. Oh, and we can also delete here, like so. Hopefully that's as simple as that. And then we can tidy things up a little bit with some refactoring. That looks good, doesn't it? So, where are we using labels? We're using labels here. So I would like to remove that and have address for here. Like so. Feels that's a somewhat unfortunate use of the variable name. Address label might be a better name there, but I will leave it for the moment. So that should still pass all the tests, but using the API we've just created, and indeed it does. That's excellent. And is there any way we can get an if statement in here? Don't think there is, and I don't think it matters. We're kind of over adding of labels here. We're continually overwriting the empty label with some value or other. But that's fine, I think. I don't really worry about that. Or do I? Or do I? I have the feeling that we could write a failing test here that merges those two uses. Because we are relying for certain instructions on the address value for the empty string being 0 because we're adding it here. So I'm going to write another failing test here, but a slightly hybrid test of the two things we've just developed. So label on the second. What should we call it? Empty label on later instruction does not break things. That's a horrible test name. So kind of what I want to say here is this: an input and a halt. And I want to do this. Assembler.assemble instructions like so, and then I want assert are equal expected program, which neither of which exist. So we can have this, and then we can say that our expected program is equal to 9010. But what I'm expecting to happen is, in this case, is this second empty label, when we extract label addresses, to set our value of this label here to 1, and this producing 9020, thus failing the test. So let us see if my intuition is correct. That is, excuse me, that is going to be the case. It should be a relatively easy fix, but it does mean that we can get slightly nicer code. That's exactly what I thought would happen. That's more indicative of what we were expecting to happen. So I think we should just be able to fix that by saying if instructions I dot label is not equal to the empty string. I don't know if I should be using it, not empty instead. I'm not sure I actually like the not empty formulation. We'll see if this passes and work from there, and have a think about what we might like to see. And that passes. That's excellent. At the very least, what we can do is we can say instruction equals instructions I. Alas, we can't do a for each kind of loop here due to needing to retain the I value. I assume there's something tucked away in modern C++ that lets you iterate over the index and the value of a vector, but I don't know offhand where that might be, and I think this is fine for now. So that's still passing. That's excellent. Are we happy with that, or would we prefer to say not empty? Label.empty equals false. Is that worse? I think this is a clearer, because we've got it up here. We're saying not empty. I mean, is that idiomatic? I don't know. I mean, that should still pass. It looks fairly horrible. If it still passes, we'll look at it. It still passes. What do we think? Not instruction.label.empty. Not is very hidden, isn't it? With the what if we were to do label equals this and do away with the instruction? Does that look better? Still works, I believe, although we have yet to see proof of this until I run the tests. If that still works, I might leave it and see if it grows on me. Yep, that still passes fine. I mean, that seems to be the idiom, doesn't it? I don't know what you'd write as a function that says string.empty or string.notempty, contentful, something like that maybe. I don't know. But I'm going to leave it now, because I think that might be what you're supposed to write, and it seems to do the job for now. Yeah. So let's just nip back and see. I don't think that there's another failing test I can come up with to do with extracting label addresses. I think that gets the job done for now. And I think it's kind of nice that we've managed to have a little program that uses both, even though there aren't any labels in this. It's there helping us. So let's commit those changes. Good. We can say extract label addresses from instructions. Good. And then that just leaves us with the parsing of the instructions and the creating of the instruction vector to complete our assembler, which we shall embark on next time.